Now, we will continue our lesson on expanding and condensing logarithms with challenging questions, but now we're just going to concentrate on condensing, or we're going to try and write it as a single logarithm. Now, we're still going to use the same three rules that we've been using, which are these three. Now, if you've been given the following, if you've been given an expression that has more than one logarithm, and you want to write it as a single logarithm, then that's what we're going to be calling condensing. Now, how do we do that? It's basically the opposite of what we did on our previous video. On our previous video, our last step was to put the exponent in front of the logarithm. So that means that when we're condensing, our first step is to put any number in front of the logarithm as an exponent, which is pretty much the opposite of what we've been doing. So if we do that correctly, we should obtain log x to the second plus log y to the 1/2. So notice that we don't have any constant in front, or any coefficient, I should say, any coefficient in front of the logarithm. So now we can apply the next rule. We see that we're adding. So that says that if you're adding, you can just multiply the insides. So that's what we're going to be doing. So now this becomes log, log x to the second times y to the 1/2. This is your final answer. Or we can rewrite this y to the 1/2. You can rewrite that as the square root of y. So that means that which is your final answer, but you can also rewrite it as log x to the second times the square root of y. Both of those answers are correct answers. So now let's look at the second example, which it looks more difficult, but it's pretty much the same process. It's just extra steps. That's all. Again, when you're condensing, the first thing that you should do is any coefficient that you have in front of the logarithm, try to bring it as an exponent. Here we see that I have a coefficient of 3. So I can rewrite that as an exponent of 3. So that becomes log x to the third. See that on the second term, I have a coefficient. So now this becomes my exponent. So now it becomes plus log 5 y to the second. Notice that on the third one, we don't have any coefficient in front of the log, so we just rewrite that. So now this becomes just log 5z. And here we have a plus 2. It doesn't even have a logarithm on it, so we're just going to rewrite that. Excellent. So now, what do we notice here? Notice that here, I'm adding 3 logarithms. I'm adding 3 logarithms here. So what does my rule says? That if you're adding logarithms, you can just multiply the insides. Now, why am I not taking in consideration that 2? Because that 2 doesn't even have a logarithm. So we're really not going to use that 2 when we're condensing this. We're just going to keep rewriting it. So back to the logarithms here. I see that they're adding. The rule says that I need to multiply the insides. So what's in red? It just becomes log, one big log, where inside it's what we had inside the previous logarithm. So that becomes log of 5, the first thing that was on the parentheses, which is to the third, times the second expression that we have in the parentheses, which is y to the second, times the third expression, which is a z plus 2. This is pretty much it. Notice how many logarithms do we have in our final answer? We have one logarithm, so we just condense it or we wrote it as a single logarithm. So lastly, let's look at example 3. Now, here's a tip. When you're adding or subtracting logarithms, the order doesn't really matter. So what I like to do is every time you see a subtraction of a logarithm, I'm just going to rewrite the expression and put that subtraction all the way to the end. So our original expression, it's okay for us to rewrite it as 3 log of x plus 2 log of z minus 5 log of y. Well, notice that every single one of them has a base 4, so I forgot to write that. Okay, so now why do we do this? Well, you will see on the next step. Because now, again, when you're condensing, your first step should always be any coefficient, bring it as an exponent. So now my first term just becomes log base 4 parentheses x to the third plus I see a coefficient of 2. So what does that happen? It comes as an exponent in that z. So now it becomes plus log 4 z of 2 minus log of 4 y to the fifth. So what should we do here? Notice that here we have two rules. Here I'm adding this 2 and I'm subtracting the last one. This is not a rule, but I always like to do addition first, and because it makes a computation even easier. So I'm gonna first apply rule number 2 to these two logarithms. So that says that if I want to condense these two logarithms, it's addition. So the rule says that if you're adding, you multiply the insides. So for the first two, I'm just going to rewrite this as x to the third times c to the second. I'm just going to rewrite that negative. So minus log 4 y to the fifth. Now, why did I did this? Because now it's even easier to identify what's the last rule. Here that I'm just subtracting, I'm subtracting two logarithms, and the third rule says that if you're subtracting, you can just divide the insides, which is going to be the left minus the right. So this really just becomes log 4. We're going to divide is the left minus the right. So now that becomes x to the third times c to the second divided by y to the fifth. And this is our final answer. Now here, for your entrance ticket, just try to condense the following. Try to write the following as a single logarithm.